Okay, so I was going to actually type out the entire game and take you through it, but I kept making so many mistakes, and you would just be watching me fix my own bugs. So what I've decided to do is just show versions of the code as the development goes on, and I'll explain, that particular stage and where we're up to, and then I'll go on to a whole new load of stuff. So what we're going to do here is just draw the grid, and get the board appearing. If we press play, that's what we get, and we're at a stage where, if you look at down here, whenever I click anywhere, I get the exact coordinate of the pixel I've clicked on, but I get the column that I'm in. So anywhere in this column, I get a 0. Anywhere in this column, I get a 1, 2, 3, 4, 5, and 6. I get it right. Okay. So standard imports, we're going to use mouse this time, obviously, and then in order to draw stuff, we actually do need to go down to this GL level, but that's reasonable. These, I have the idea that later on we'll be able to change the size of the grid and the size of the pieces and the color of the pieces and bits and pieces like that. So I'm beginning to define some sort of module-wide constants which you can tinker around with, and it works already to change the column width, for instance, and since that's equal to the row height, you can change the size of the grid. If we make that 50, you just get a smaller grid. Okay, so the mouse press just intercepts the X and Y, which is passed in to us by Piglet. Check that it's the left mouse button, and then print this stuff. Let's quickly look at this column X function, which I've made. It's very simple. It just takes the X coordinate and divs it by the column width. So that gives us the quotient, but not the remainder. So if you're anywhere up to the column width, it's going to give you 0. If you're anywhere between 1 and 2, it's going to give you 1, and so on. So it effectively gives us the column number. That's fine. Update, we're not doing anything with at the moment. This special statement in Python allows you to sort of put a placeholder in there without generating an error. If I deleted that, we'd get an error here. It wouldn't like the fact that we've got a function with nothing in at all, but pass obviously does nothing. And then we have this draw event. What we're going to do essentially is erase everything and then draw everything, and the only thing we're drawing so far is the grid. So let's talk about how that works. First of all, I made this function here to draw a line, and I decided that we needed the coordinate of where the line starts, the coordinate of where the line finishes, and a color for the line, and I've made it a default of white. This call to graphics.draw looks complicated, but it's not too bad. This thing here, this number here, says that we are going to provide 2 vertices, and you can see the vertices here. If I put a third one in there, x3 and y3, I'd get an error because of that 2. So that's what that 2 is doing. This is the mode of drawing, so the GL module isn't going to do any filling in here because we've told it we only want lines. And then we have to give 2 tuples. There's the first one from this bracket right up to there, and there's the second one. And the way those tuples are constructed are a string to provide some information about the rest of the tuple, and then the rest of the tuple itself. In this case, vertices first. V says that we are providing information about vertices. We have 2 coordinates per vertex, so we're looking at 2D here, only x and y rather than x, y, and z, and I, that they are going to be integer numbers. You can have an f there, you can have v3f, for instance, which would say a 3D vertices as floats, and in fact we will use floats later on, but at the moment they're just indices, and then I can just pass in one single tuple with the correct number of vertices, which are interpreted as in place. You can actually tell GL to interpret them in a different order, but there's no need to here, so I'm just going to make sure I give them x1, y1, x2, y2, and it will interpret those properly. Now, the next one here says that we're talking about color, and we are going to have 4 bytes per color, and that's what this is, which is RGB alpha. Alpha doesn't seem to make any difference, but I put it in there just in case in the future we want to do something with it. There's some reason I read something, I can't really remember what it said. I have to put in 1 color per vertex, and since I'm putting in 2 vertices, I have to put in 2 colors, and the easiest way of doing that is just to multiply this tuple that I've been given by 2 here, and it's happy with that. You can actually have different colors, which will mean that the line is drawn sort of going from one color to another, and if you do that with 2D shapes, you can get some really nice effects really quickly, but I'm not worrying too much about that. So all this does is draw a line from x1, y1 to x1, x2, y2 in this color. And I then quickly use that to draw a grid. So here we're running I up to the number of rows, which means we're sort of going, let's get this right, we're going upwards here, are we not? So our x coordinate starts off as, our x coordinate of our first point is 0, and then it goes up to the window width. So we're going right the way across the screen, and our y coordinate steps in multiples of row height. So the first one's low, then it goes up a bit, then up a bit, then up a bit, then up a bit. And on the next one, we're doing columns. So this time our y coordinate, it starts off as 0 and ends up being high, and it's our width that it's our x coordinate that grows in increments of column width, and that's what draws our grid. Other stuff, we're just updating every 15th of a second, which is absolutely fine, and then we show the window. So that's that for the first video.